Okay, I'll once again welcome you to today's lecture. In our previous lecture, we looked at how to plug in values within a function, and for today's lecture, we are going to look at the composite functions. So, under composite function, I'll start by giving examples. The first example will be given that at A we have FG, and then at B we have GF. So we want to look for FG and then GF, and at the same time the functions that are given here are f of x to be 10 plus x, and at the same time g of x to be x cubed. Now, how do we find fg and gf? So let's start with the solution to these questions. For part A, we'll have fg. So fg means we plug g of x into f. Now if you plug g of x into f, and our g of x is x cubed, it's like I'm plugging in x cubed into f, which will give me 10 plus x cubed as my answer. Then for part B, I'll have g of f, which will give me g, you plug in f of x. So if you plug in f of x, it's the same as g into our f of x here is 10 plus x. So where there is x, we put 10 plus x. And then our g is x cubed. So this one means 10 plus x cubed. Given that f of x is equal to 5x plus 1, and that g of x is equal to x squared, then you're supposed to express the composite functions, that is f of g and g of f in their simplest form. So the solutions to these, the solution to that question for part A, which is f of g, which can also be written as f into g of x, of course. So we are plugging in g of x into f. So this one implies f into what we have within g of x, which is x squared. So we only plug in x squared where we have x. So this one will give us 5 into x squared that we are plugging in instead of x plus 1. So this one, if you work out, you'll get 5x squared plus 1 as our answer for part A. Then for part B, so in part B we have, in part B, remember we had our g of x as x squared, and we also had our f of x as 5x plus 1. So in part B we want to find g of f, which implies plugging f of x into g, which is the same as g into bracket f of x, that is 5x plus 1. We plug it in into g. So if you plug that into g, this one will give us g into 5x plus 1 will be equivalent to this one squared, which is 5x plus 1 squared. And if you square this, we'll get this one squared, which is 25x squared, then plus this times this, which is 10x, and then 2 times 5, then 1 squared, which is 1. So for this one, you simply square this, 5x times 5x, which is 25x. Then for this one, you simply take this times this times this, which will give us 10x, and then you square the last one, which gives us 1. This is by using a quadratic identity. Okay, so that is under the composite function. Composite function. Then the next substance that I'd like us to look at is the inverse of a function. The inverse of a function. The inverse of a function. And when you want to find an inverse of a function, there are several steps that you're supposed to follow, which we can look at by looking at an example. So let's consider a function. Consider a function. Consider a function f of x to be equivalent to 1 over 8x cubed plus 1. If we are given a member, if we are given a member of the range, say f of x to be equivalent to 9, then it is possible to find the corresponding member of the domain. So the inverse of a function, I want us to look at inverse of a function. So consider the function f of x is equal to 1 over 8x cubed plus 1. So if we are given a member of this range as f of x is equal to 9, that is, the function is equivalent to 9, then at times it is possible to find the corresponding members of the domain, whereby the corresponding members of the domain are the x. Now, how do we go about that? So we can only go about that by simply finding the inverse of the function first. Now, how do we find the inverse of a function? So an example to this, example, find the inverse of the same function that we were given, which is f of x is equal to 1 over 8x cubed plus 1. The solution to this is we have the function as f of x is equal to 1 over 8x cubed plus 1. Replace f of x with y so as to have y is equal to 1 over 8x cubed plus 1. And then we make x the subject of the formula. So if I want to make x the subject of the formula, I'll bring 1 this side so as to have y minus 1 is equal to 1 over 8x cubed. Then you can multiply both sides by 8. So this one gives me times 8 times 8. So this one gives us 8 into bracket y minus 1 is equal to x cubed. So that our value of x here becomes cube root of 8 into y minus 1. So when you're writing the inverse of this function, you write it in this form. So this one will be written as f of x, where f is inverse, is equal to 3, the cube root of 8. And then instead of having y, we now replace it with x minus 1. So our inverse will be that. So we can even go ahead and use that of our inverse to find the same as the domain. So I've said that our inverse is x, which is equivalent to 8 of x minus 1. Okay, so that is our inverse. Now, if we look at the equation in the previous part, we were told that the function is equivalent to 9. Now, if the function is equivalent to 9, that is the inverse of the function. The inverse of the function will give us now the domain, which will be the inverse of 9, which if we plug in 9 into the inverse here, if we plug in 9 into the inverse, we'll have cube root of 8 into bracket 9 minus 1, which gives us cube root of 8 times 8, which is cube root of 64. And cube root of 64 is the same as 4. So it means that the inverse of a function can give us the domain part of it when you are given the codomain. We can as well prove this by just working it out the way it is. Let's prove and see if this 4, we can get 4 when you are given the codomain as 9. So f of x is 9, but what is our f of x? F of x you are given to be 1 over 8x cubed plus 1. So if we replace 9 here with f of x, we'll have 1 over 8x cubed plus 1. Bring this one this side, it will be 9 minus 1, which is 1 over 8x cubed. Then this is 8 is equal to 1 over 8x cubed. Multiply both sides by 8 so as to get x cubed, which is this, is equivalent to 64. So if I want to get the value of x, I'll simply get the cube root. So x will be the cube root of 64, which still gives me 4. So this one proves that we can at times use the inverse to find the domain of a function. Example 6. In example 6, we have let f of x be equivalent to 5x plus 7 all over 3x plus 2. Then find f inverse of x. So how do we get f inverse of x? So this one will give us, first of all, when you're looking at the solution, we write f of x in this form, 5x plus 7 all over 3x plus 2. So we replace this f of x with y, so as to have y is equal to 5x plus 7 all over 3x plus 2. Then we can cross multiply this, putting this over 1. So this one will give us y into 3x plus 2 is equal to 5x plus 7. Then we can work that out. So when you're working this one out, we'll have the equation is y into bracket 3x plus 2 is equal to 5x plus 7. When you distribute, we'll have 3xy plus 2y is equal to 5x plus 7. collecting the like terms here. Okay, for us to collect the like terms, let's bring 5 this side so as to have 3xy. Okay, 3xy minus 5x then is equal to 7. Then you can take these 2y this side so as to become minus 2y. So this one will give us, if we factor out x, we'll have 3y minus 5, which is 7 minus 2y. Then we can divide both sides by 3y minus 5 into 3y minus 5. So that this and this goes. So my value of x will be 7 minus 2y all over 3y minus 5. Then you can now have the inverse as f of x, which is inverse, is equivalent to 7 minus, so wherever we have y, we change to x, which is 2x, and then 3x, we change that to x minus 5. So this one becomes our answer. Then that's the inverse. Then we can again look at another example. Another example. So let's look at another example 7. So in our example 7, we can write, given that f of x is equal to 5x plus 1, find the values of f inverse when we plug in 36, and then part B, f inverse when we plug in 0. So first of all, we start by getting the inverse of this. The solution to this equation, we'll have 5 into x is equal to 5x plus 1. Then I said that we replace this f of x with y so as to have 5x plus 1. Then we make this x the subject of the formula, bring 1 this side, we have y minus 1 is equal to 5x, divide both sides by 5, so as to have x is equivalent to y minus 1 all over 5. Then we can write that as our inverse. So our inverse will be f x is equivalent to y minus 1 all over 5. Then when you look at in our equation, we are supposed to solve part A, which is f inverse or plugging in 36. So if you plug in 36 here, then I said previously that when you're writing the inverse, the y now changes to x. So we'll have this one as our inverse. Plug in 36, we'll have 36 minus 1 over 5, which is 35 all over 5. The answer becomes 7. Then the last part, which is f inverse, we plug in 0. So when we plug in 0, here we'll have 0 minus 1 all over 5, which is negative 1 all over 5. So these are the answers. So we have solved our equation. Otherwise, thank you and welcome in the next video.